Hello and good day to you out there wherever you are in the world. This is Sam Olanik and welcome you to this channel at the Sam Online Academy. So in this lesson, this is our series. This is our fourth lesson on motion. So in this lesson, we're looking at acceleration. In our last lesson, we looked at average velocity, average speed. So today we're looking at acceleration. So before we move ahead, hit the subscribe button. If you know you're not yet subscribed to this channel, please go ahead and hit the subscribe button and also like the video. And if you have any comments at the end of the video, you can go ahead and drop your comments. So we are going to proceed right away. What is acceleration? Acceleration can actually be defined as the rate of change of velocity move with time. Acceleration can be defined as the rate of change of velocity move with time. And since velocity is a vector quantity, acceleration is also a vector quantity. Okay? It's also a vector quantity. Speed is a scalar quantity. Velocity is a vector quantity. So acceleration is a vector quantity. Acceleration has direction. If acceleration is completely stated, it's going to have direction as well as magnitude. The unit of acceleration is meters per second square, which can be written this way, or it can be in kilometer per hour square, written this way or this way. The unit for speed and velocity is meters per second, which can be written this way or this way, or kilometer per hour, which can be written this way or this way. This is for speed or velocity, but this is for acceleration. These are the units for acceleration. There are other units that can come up. So when you combine units of distance and time, you have acceleration, but the time has to be squared. But for velocity and acceleration, there is no square in the time. Okay. So we are going to march ahead with acceleration. I have already defined acceleration as a rate of change of velocity moving time. Okay. So acceleration can be positive. It can also be negative. When velocity is increases from a value to a higher one, then the body is said to be accelerating. Acceleration is positive. But when the velocity decreases, let's assume I was running at a speed at a point and now decrease my speed, or I was walking. As I was going forward, I now decrease my speed at which I was walking, and now decrease my velocity. Then acceleration is going to be negative. In that case, a negative acceleration is referred to as deceleration or retardation. Either it is called retardation or deceleration. So from this problem, this journey here, we are going to use it to calculate acceleration at different points, at point A, point B, point C, point D, point E. We are going to calculate this acceleration of the boy that was running. So first and foremost, we need to get the velocity at point A, velocity at point B, velocity at point C, velocity at point D, velocity at point E. Okay, to be able to do that. So we are going to calculate the acceleration from A to B, B to C, C to D, D to E. First and foremost, we need to get the velocity at point A. So what's the velocity of the boy at point A? Since at point A was where the boy commenced running. At point A, he was standing. His velocity was 0. He was at rest. In physics, when they say something is at rest, that means it's not moving. It was not moving originally. So at that point, his velocity is going to be 0 meters per second. So at this point, the velocity of the ball is 0 at A. The velocity at A is 0 meters per second. But when it starts running, its velocity is not going to be 0 anymore. Okay. So at B, he has commenced running already. It took him 20 seconds to cover that distance of 100 meters. And 100 divided by 20 now is 5. So velocity at B is 5 meters per second. Okay? The new velocity at B is 5 meters. Okay. Now, from B to C, 100 divided by 10, listen, 100 divided by 10 seconds, 100 meters divided by 10 seconds, that is 10 meters per second. So the velocity at C, which we calculated this in the previous video, velocity at C is going to be 10 meters per second. Then, the same thing. What is happening between B and C is what is happening between C and D. So the velocity at D is still going to be 10 meters per second. Then the velocity at E, this is going to be 100 divided by 25. Hello, sorry, I just want to ignore the analysis we've just done so far. So now let me cancel the distance between C and D. But now I just want to assume this is the ball was started out here. Started running here. So we take it that the velocity here is 0 meters per second. By the time it got to B, the velocity had increased to 5 meters per second. Velocity at B increased to 5 meters per second. So I don't want to take the distance into consideration. Okay. So let me just ignore the distance. So by the time it got to C, the velocity had increased, doubled to 10 meters per second. Then the velocity now remained constant from C to D, still at 10 meters per second. Then when it got to E, it decreased to 4 meters per second. Then the ball now ran further and stopped at F. The ball ran further and stopped at F. At this point, the velocity was 0 meters. Okay. At F, the velocity was 0 meters. Okay. So, let's calculate the acceleration between A and B. We are going to calculate the acceleration between A and B. So, between A and B, remember, I define acceleration as the rate of change of velocity moving time. So acceleration mathematically is equals to final velocity. Final velocity minus initial velocity all over total time taken. So in this case, the symbol that is used for final velocity is going to be small v. We are going to use small v for final velocity, while we use small letter u for initial velocity. Okay, so we're going to use small letter v for final velocity and small letter u for initial velocity. Now, between A and B, at A we have the initial velocity, at B we have the final velocity. So at A, initial velocity was 0 meters per second. That the ball was just at that point, that was where it commenced running. His velocity was initially 0. It was at rest. So his velocity is going to increase from 0 at A. So the final, which is at B, is 5 meters per second. At A, velocity is 0. So his final velocity, V, is 5 meters per second. Now, T, the time taken is equals to 20 seconds. Okay? So, acceleration formula, let me use it in symbols. Acceleration, we're going to use small letter A, is equals to V, small letter V minus small letter U all over T. T is the time taken, V is the final velocity, U is the initial velocity, A is acceleration. So, the acceleration between A and B is going to be, based on this formula, is going to be, our V is what? 5 meters per second. Our U is 0 meters per second. All over 20 seconds. So 5 minus 0 gives us 5 meters per second. All over 20 seconds. 5 divided by 20. That will give us 0.5 here 1, 5 here 4. This is going to give us 0.25 meters per second square. So acceleration between A and B is 0.25 meters per second square. Okay? So acceleration between A and B is what? 0.25 meters per second square. Now we are going to move to acceleration between B and C. At B, B is where we now have the initial velocity now. At C, we have the final velocity. The T time is 10 seconds. So we have V. We have V 10 meters per second. We have U equals to 5 meters per second. We have T equals to 10 seconds. The time, 10 seconds here. This is V, 10 meters per second. This is U, 5 meters per second. This is the initial. Now, this is the final. Initial is where the velocity is commencing. The final is where it is ending. At this point, the journey starts here, ends here. This is the time, 10 seconds. So based on this formula, A is equals to V minus U over T. We have that velocity between B and C is equals to 10 meters per second minus 5 meters per second all over 10 seconds. 10 minus 5 is 5 all over 10. This is 5 here 1, 5 here 2. This is 0.5 meters per second square. So 5 divided by 10 is what? 0.5 meters per second square. 0.5 meters per second square. 0.5 meters per second square. Okay. So we are going to go ahead. I just want to get some space here. The acceleration between C and D. Let's see. Acceleration between C and D. So this is the commencement. This is the initial U, and this is the final V. This is the time taken, 10 seconds. So there at CD, between C and D, initial is 10 meters per second. The final is also 10 meters per second. Okay. So the velocity remained constant. This was uniform velocity. So let's see how that is going to tell on the acceleration. The time is time taken there is what? 10 seconds. So still using this formula, A is equals to final velocity V minus initial velocity U all over time taken T. We have that. We have 10 meters per second minus 10 meters per second all over the time, which is 10 seconds. 10 minus 10 is 0. So, okay, let me take it over here. 10 minus 10 is 0 meters per second all over 10 seconds. 0 divided by this by 10 is 0 meters per second square. So the acceleration is 0 meters per second. So automatically here, what is happening is that there is no acceleration. The boy did not accelerate. Why didn't he accelerate? Because the velocity between at point C and at C did not change, remain the same. So whenever there is uniform velocity or uniform speed, that body, that object doesn't undergo acceleration. It doesn't undergo acceleration, it doesn't undergo retardation, it doesn't undergo deceleration. When a body is moving at uniform speed, uniform velocity, it does not undergo acceleration. So the speed here, the velocity here was 10 meters per second. At this point, it still remains at 10. So by the time we subtracted, it was 0. We divided by the time, it was 0. No acceleration. So I believe you now understand. This is a case of no acceleration. The body was moving with uniform speed. It was moving with uniform velocity. So there is no acceleration there. From A to B, acceleration was 0.25. At B to C, acceleration increased to 0.5. So acceleration increased at B. At between A and B, acceleration was 0.25. Between B and C, it increased to 0.5 meters per second square. But over here now, between C and D, there is no acceleration. No acceleration occurred. So let's go to D and E. At D and E, what is happening at D and E? Let's look at what is happening at D and E. At D, we have the initial right now. The initial velocity is 10. At E, we have the final. The final is 4. The time taken is 25 seconds. So, using this formula, A is equals to V minus U over T. What do we have? We have that A is equals to, our V is what? 4 meters per second. So, we have 4 meters per second minus U, which is 10 meters per second, all over T, which is 25 seconds. That is the time taken, which is 25 seconds. So 4 minus 10 is minus 6 meters per second, all over 25 seconds. So let's divide 6 divided by 25. So I'm going to punch my calculator to find the value. So the answer is minus 0.24. So we had minus 6 here divided by 25. So we have minus 0.24 meters per second square. So we have minus 0.24. All along we've been having positive value. Why are we having the minus now? What is the implication of the minus? The implication of the minus tells you that there is a retardation, there is a deceleration. This means that the velocity, instead of increasing, was decreasing. The velocity actually decreased from the initial value to the final value. The initial value was bigger than the final value. So this is a deceleration. This is a retardation. It's just like the body was slowing down. You are running at a high speed. All of a sudden, you started reducing your speed. This is what actually occurred in this instance. The body actually slowed down. It's just like when a car brakes or a car reduces its speed, reduces its velocity from a high velocity, a high speed, to a lower velocity. That was what happened here. That is why we have a negative value. This is a retardation. Okay, this is actually a retardation. Okay, so if you are to state this, they might tell you, if they tell you the acceleration is minus 0.24 meters per second square, but if they use the word retardation, they won't add the minus. The retardation is 0.4 meters per second square. If they use the acceleration of retardation, they won't add the minus, but if they use acceleration, they are going to attach the minus. Okay, so what is the acceleration? Minus 0.24 meters per second square. What is the retardation of the acceleration? 0.24. The word retardation acceleration already tells you that it is a minus. The velocity is actually decreasing. Okay, so I believe you actually understand that. So from A to B, the acceleration was positive. That means velocity was increasing. Yeah, velocity increased from 0 to 5. Yeah, it increased from 5 to 10. In these cases, we had acceleration. Yeah, it was 0, no acceleration. There was uniform velocity, uniform speed, no acceleration here. Then here there is a retardation. And finally, from E to F, the body comes to rest from a speed of 4 meters per second to a speed of 0. So let's take that. The time it took for that to occur was 20 seconds. So you calculate the acceleration there. You are going to do that by yourself. Over here as well, what you are going to have is a retardation, a deceleration. You are going to end up with a negative value. Why? Final velocity is 0, initial velocity is 4. So you can go ahead and calculate that and solve that by yourself. So let me briefly just summarize what we did. We worked on acceleration in this lesson. I explained that acceleration is the rate of change of velocity moving time. Okay, so and I gave this part where from the beginning the body start at rest. When you pay attention very much, when you hear a body starting at rest, that means the body is starting from zero velocity, 0 meters per second, zero velocity. The body wasn't moving, it just commenced moving. So it's just like you are about to run. At that spot you're about to run, your velocity is zero. Immediately you start running, your velocity will start to increase. So that was what happened. This boy, at this point, his velocity was zero. He was about to start running. He had not started running. When he started running, his velocity increased to 5 meters per second. This became the final. The 0 was the initial. Between B and C, 5 was the initial, 10 was the final. Yeah. When we calculated, the value was positive at the end of the day. It took a time of 10 seconds for him to move from 5 meters per second to 10 meters per second. Between C and D, the velocity remained the same. 10 at C, still 10 at D. Yeah, the body didn't accelerate, velocity didn't increase, speed didn't increase. Speed was constant, velocity was constant. So uniform velocity can also be described as constant velocity, no acceleration. So from D to E, velocity now decreased from 10 meters per second to 4 meters per second. There was a retardation here. There was a deceleration here. That was all. When we calculated, we got a negative value. Then from here, the boy now went to rest. Here he was still running, but at this point, he stopped running. When he got here, the velocity, for him to stop running, the velocity must decrease to 0 again for him to stop running. So you are going to do this calculation yourself, and you can drop the answer in the comment section. Okay, so with this right now, we've come to the end of this lesson. If you have any question, you can drop them in the comment section and I'm going to respond to them. Thank you so much and God bless you. So if you have any question, like I said, drop them in the comment section. So I provided my WhatsApp number at the beginning of the lesson, and you can connect with me via my Instagram handle as well. And if you're not subscribed to this channel, please ensure you do. Make sure you subscribe. So if you have any question, you are free to go ahead and channel your question. So this is this was our lesson 4. So far we've looked at in the first lesson we looked at distance, displacement, time. Then we had a lesson where we looked at velocity and speed, and we had a lesson where we looked at uniform speed, uniform velocity. We looked at average speed, average velocity. We looked at acceleration. So in our next lesson, we'll be going to solving calculations relating to speed, calculation that has to do with motion, calculation that has to do with speed, velocity, time, acceleration. So watch out for our next video. Thank you so much and bye, and God bless you.